Hello, this is O-Level Chemistry in Excel, section number 1, Principles of Chemistry. A. States of matter. What are the three states of matter? Solid, liquid, and gas. What are the differences in arrangement, movement, and energy of particles in the three states? Arrangement, movement, and energy of particles in solid, liquid, and gas. For solid, the particles are regular and close together. For liquid, particles are irregular or random, but still close together. For gas, particles are also irregular or random, but they are far apart. So particles in liquid and gas are irregular, but particles in liquid are close together and particles in gas are far apart. Particles in gas are more random than particles in liquid, and particles in solid are closer together than particles of liquid. That's for the arrangement. For the movement, particles of solid vibrate in fixed positions. Vibrate in fixed positions. Particles in liquid slide past each other. Slide past each other. Or you can write, they move slowly. Move slowly. For particles of gas, they move rapidly. Move rapidly. You can say move randomly or freely. Move freely or move randomly. So particles of gas move faster than particles of liquid. Particles of solid only vibrate in fixed positions. For the energy, solid particles have the least energy. Lowest energy. For particles of gas, they have the highest energy. Highest energy. Particles of liquid are moderate energy. They are intermediate between the particles of solid and particles of gas. The energy of liquid is intermediate between solid and gas. That's for the first point in states of matter, the differences between arrangement, movement, and energy of particles in the three states. Second, changing state. Changing state. That's point number 2 in section number 1. Changing state from solid to a liquid is called melting, and the reverse process, returning back a liquid to a solid, is called freezing. Changing a liquid to a gas is called evaporation or boiling. Returning back a gas to a liquid is called condensation. If a solid turns directly to a gas without passing through the liquid state, this is called sublimation. If a gas returns back to a solid without passing through the liquid state, it's called deposition. Then, what's sublimation? Define sublimation. It is the change of state from solid to gas directly without passing through the liquid state. Without passing through the liquid state. You can write equations for melting and freezing and boiling or evaporation and condensation and sublimation and deposition of water. For example, equation for melting: H2O solid gives H2O liquid. This is melting. For freezing, H2O liquid gives H2O solid. For boiling, H2O liquid gives H2O gas, boiling or evaporation. For H2O gas to H2O liquid, this is condensation. For H2O solid to H2O gas, this is sublimation. H2O gas to H2O solid, this is deposition. So what are the differences between evaporation and boiling? First, evaporation takes place at the surface. So only particles at the surface can escape to the gaseous state. For boiling, it occurs throughout the whole liquid. So particles throughout the whole liquid can escape to the gaseous state. This is the first difference. The second difference is that boiling is faster than evaporation. Boiling is faster than evaporation. Third difference, during boiling, there are bubbles. During evaporation, there are no bubbles. Fourth difference between evaporation and boiling is that evaporation takes place at any temperature, but boiling occurs at the boiling point of a substance. So there are four differences between evaporation and boiling. Evaporation takes place at the surface. Boiling takes place throughout the whole liquid. Evaporation is slower than boiling. Boiling is faster than evaporation. During boiling, there are bubbles, but during evaporation, there are no bubbles. Boiling takes place at the boiling point, but evaporation takes place at any temperature. If this liquid is water, then the gas produced from evaporation is called water vapor. But the gas produced from boiling is called steam. This is the difference between gaseous water produced from evaporation and gaseous water produced during boiling. So if you are asked for the two names of water in the gaseous state, you can say water vapor and steam. There is a question asking for why the rate of evaporation increases by heating. Explain why rate of evaporation increases by heating. At higher temperature, particles gain more energy. So more particles can escape the surface, and more particles can escape the surface easier. So at high temperature, particles have more energy, or particles may gain more energy. Particles gain more energy. So more particles can escape the surface easier. Or just you can say more particles can escape the surface. What happened to the energy and arrangement and movement of particles during changing of state? When a solid melts into a liquid, particles become random. They stay close together, but not as in solid. They start to slide past each other, or we can say they move slowly, and particles gain energy. During boiling, particles become far apart and more random. They move rapidly and freely and randomly everywhere, and they gain energy. During condensation, particles become close together, they move slower, and they lose kinetic energy. During freezing, particles become irregular, they vibrate at fixed positions, and they lose energy. The scientific term for adding energy to a substance is called endothermic. So melting and boiling are endothermic processes. And the scientific term for removing energy is called exothermic. So condensing or condensation and freezing are exothermic processes. The first example for sublimation is sublimation of dry ice. Sublimation of dry ice. Dry ice is solid carbon dioxide. Solid carbon dioxide exists only below 87 degrees Celsius. If carbon dioxide, solid, dry ice, is held in air, it sublimes. It turns directly to carbon dioxide gas. So at room temperature, 25 degrees Celsius, and room pressure, 1 atmospheric pressure, carbon dioxide only exists as a gas. So during sublimation of dry ice, carbon dioxide solid turns to carbon dioxide gas. The only way to see carbon dioxide liquid is to place dry ice in a sealed tube. So if dry ice, which is solid carbon dioxide, is placed in a sealed tube, and you start to heat the tube gently, first carbon dioxide solid will sublime to carbon dioxide gas, then the pressure inside the tube will increase greater than 1 atmospheric pressure. In this case, some carbon dioxide will melt, giving CO2 liquid. The first equation is sublimation, and the second equation is melting. This is carbon dioxide solid, which is dry ice, and the white fog is due to the condensation of water vapor in air. Condensation of water vapor in air due to the very low temperature of dry ice. So dry ice condenses water vapor in air. When it sublimes, it absorbs energy from the air, so the air cools down and water vapor in air condenses. Another example is sublimation of solid iodine. Sublimation of iodine. Some solid iodine crystals, dark gray crystals, are placed in a beaker. Dark gray crystals of solid iodine are placed in the bottom of a beaker and gently heated. Iodine sublimes. It turns from iodine solid to iodine gas directly without passing through the liquid states. Gas is iodine, fills the beaker. It has a purple color. If a cold flask containing ice is placed on the top of the beaker, then the purple iodine vapor will deposit into solid iodine. يبقى first equation is sublimation of solid iodine to gaseous iodine, and the second equation is deposition of gaseous iodine to solid iodine. Iodine also can melt from iodine solid to iodine liquid, I2 liquid, if it's heated to 113.8 degrees Celsius. This is the melting point of solid iodine. So if you heat solid iodine gently, it will only sublime. But if you heat solid iodine strongly, up to 113.8, iodine would melt. This is the sublimation of iodine. In the photo, the particles which deposit on the flask are solid iodine particles, dark gray. And the purple vapor is iodine gas. Another example for sublimation is sublimation of ammonium chloride. Sublimation of ammonium chloride. First, what is the formula of ammonium chloride? Ammonium chloride has the formula NH4Cl. It's a salt, a white salt. It's an ionic compound containing both ammonium ion and chloride ion. Don't confuse between ammonium chloride and ammonia. Ammonia is a colorless gas and it's a base. Ammonium chloride is a white solid. It's an ionic compound consisting of ions, ammonium ion and chloride ion. But ammonia is a covalent compound. It's a colorless gas. The experiment starts by placing some solid ammonium chloride at the bottom of a test tube. Solid ammonium chloride. It's a white solid. Then you gently heat under the test tube so ammonium chloride starts to decompose. During decomposition, one of the 4 hydrogen atoms goes to chlorine to form hydrogen chloride, HCl. It's a colorless gas called hydrogen chloride. Hydrogen chloride. Don't say hydrochloric acid, because hydrochloric acid is a solution of hydrogen chloride. But this is a gas, hydrogen chloride. So when one hydrogen atom from ammonium goes to chloride to form hydrogen chloride, 3 hydrogen atoms are left with nitrogen to form ammonia gas. It's a colorless gas called ammonia. So the mixture of colorless gases, ammonia and hydrogen chloride, are present here inside the test tube. This is the colorless mixture of gases. Colorless mixture of gases. At the top of the tube, the reverse reaction occurs. Ammonia gas reacts with hydrogen chloride. The hydrogen atom from hydrogen chloride returns back to ammonia to form the white solid ammonium chloride. So at the top of the tube, white smoke of ammonium chloride is reformed. White smoke of ammonium chloride is reformed. We can classify equation number 1 for the reaction taking place at the bottom of the tube as thermal decomposition, because ammonium chloride breaks down by heat. into two different substances, ammonia and hydrogen chloride. So this reaction is called thermal decomposition. Second, it's an endothermic reaction because it absorbs heat energy. Endothermic reaction. And because solid ammonium chloride turns directly to gaseous products, then we can classify the reaction as sublimation. So equation number 1 for the reaction taking place at the bottom of the tube is thermal decomposition, it's endothermic reaction, and it's sublimation. For the reverse reaction, which is represented by the equation number 2, first, ammonia is a base, hydrogen chloride is an acid, ammonium chloride is a salt, so we can classify this reaction as neutralization reaction because acid reacted with base to form a salt. Second, since reaction number 2 taking place at the top of the tube is the reverse of reaction number 1 taking place at the bottom of the tube, and since reaction number 1 is endothermic, therefore reaction number 2 is exothermic. Third, because gaseous reactants, ammonia and hydrogen chloride, are converted into solid product directly without passing through the liquid state, so this is deposition. So equation number 1 is thermal decomposition, it's an endothermic reaction, and it's sublimation. For equation number 2, it's neutralization and exothermic and deposition. So don't forget that the white smoke formed at the top of the tube is ammonium chloride, solid ammonium chloride, which appears as white smoke. Equation number 1 and equation number 2 can be written in a single equation. Ammonium chloride, solid, decomposes into ammonia gas and hydrogen chloride gas, and ammonia and hydrogen chloride gases returns back to ammonium chloride. This is an example for a reversible reaction. Remark: for ammonium chloride, how many different elements are there in ammonium chloride, and how many atoms and how many ions? For ammonium chloride, there are 3 different elements: nitrogen, hydrogen, and chlorine. 3 different elements: nitrogen N, hydrogen H, chlorine Cl. How many atoms are there in ammonium chloride? There is 1 nitrogen atom. 1 nitrogen atom. 4 hydrogen atoms. And 1 chlorine atom. So there are 6 atoms inside ammonium chloride. How many ions are there in ammonium chloride? Ammonium is an ion and chloride is an ion. So there are 2 ions in ammonium chloride. 2 ions. Ammonium ion and chloride ion. Another example, CuSO4, copper 2 sulfate, .5H2O, cold hydrated copper 2 sulfate. How many elements are there in copper 2 sulfate, .5H2O, and how many atoms and how many ions? In hydrated copper 2 sulfate, there are 4 elements: copper, Cu, sulfur, S, hydrogen, H, and oxygen, O. So there are 4 different elements in hydrated copper 2 sulfate. How many atoms? One copper atom and one sulfur atom. 5 by 2 hydrogen atoms give 10 hydrogen atoms. Here are 4 oxygen atoms, and 5 by 1 يبقى 5 oxygen in water. So 4 oxygen in copper sulfate and 5 oxygen atoms in water. So the total is 9. So there are 21 atoms in hydrated copper 2 sulfate. The last point, how many ions are there in hydrated copper 2 sulfate? Copper sulfate is an ionic compound. It consists of copper 2 positive ion called copper double I and sulfate ion. So there are 2 ions in hydrated copper 2 sulfate. Water molecule is covalent molecule, so it doesn't consist of ions. So in hydrated copper 2 sulfate, there are only 2 ions.